Let's suppose you live in a world where geographical barriers disappear in an instant, where you can be anywhere on the planet, or even on other planets, with the simple touch of a button. This is the revolutionary potential of teleportation. Currently, teleportation technology is heavily focused on the quantum level, where individual particles like photons and electrons are teleported instantly from one place to another. This process, known as quantum teleportation, has been demonstrated in laboratories worldwide. Scientists have managed to teleport quantum states of particles over small distances using the phenomenon of quantum entanglement. In this phenomenon, two entangled particles share quantum states, so that measuring one instantly affects the other, regardless of the distance between them. As research advances, scientists are seeking ways to scale these experiments to include more complex systems. One of the current challenges is maintaining quantum coherence in larger particles and multi-phase systems. This involves creating highly controlled environments and overcoming significant technical challenges, such as the loss of quantum information due to decoherence. Researchers from institutions like the University of Science and Technology of China have made remarkable progress. An example is the teleportation of photons between the Earth and an orbiting satellite, demonstrating the feasibility of teleportation over long distances and under more adverse conditions. In the future, the goal is to evolve to the teleportation of larger objects and eventually humans. This would require not only teleporting quantum states, but also completely reconstructing an object or person at another location, atom by atom. This concept is still in a theoretical stage and faces enormous technological and ethical barriers. However, experts like physicist Michio Kaku suggest that with the continuous advancement of quantum science and the miniaturization of technology, we could see the first prototypes of teleporting small molecules within a few decades. Interviews with leading scientists like Anton Zeilinger and Jianwei Pan reveal cautious optimism, highlighting that although we are in the early stages, the scientific foundations are being laid for a technological revolution that could transform how we live and travel. And teleportation raises not only technological and scientific questions, but also profound philosophical issues about identity and continuity. The paradox of the ship of Theseus is often used to illustrate these dilemmas. In the paradox, a ship has all its parts gradually replaced over time. The question is whether, at the end of the process, it is still the same ship. Applying this to teleportation, we can ask, if all parts of a human being are dismantled and reassembled elsewhere, is that person still the same? The question is not just of a physical nature, but also involves the essence of our identity and the continuity of consciousness. The issue of continuity of consciousness is central to this discussion. Consciousness can be seen as a continuous flow of experiences and memories that define who we are. If this flow is interrupted by teleportation, with the original being destroyed and a perfect copy created elsewhere, the question arises, does this copy have the same identity as the original? Many philosophers argue that physical continuity is crucial for personal identity, suggesting that a copy, even if identical in all aspects, is not the same person because continuity has been broken. Neuroscience also contributes to this discussion by exploring how consciousness and identity emerge from brain function. Studies in neuroplasticity show that the brain is constantly changing, reinforcing the idea that identity is dynamic and not static. However, transplanting or replicating an entire brain presents significant ethical and technical challenges. Some neuroscientists, like Christoph Koch, suggest that consciousness may be an emergent phenomenon that cannot be simply transferred or replicated. Thus, while teleportation technology continues to advance, the discussion about what it means to be you persists, raising questions that may never have definitive answers. The advent of teleportation would bring profound and transformative ethical and social implications. One of the most immediate changes would be the elimination of distance barriers, allowing people to move instantly anywhere in the world. This could revolutionize the job market, enabling individuals to work remotely in real time in different countries and time zones. Imagine the ease of attending a business meeting in New York and then having lunch in Paris, all within the same day. However, this ease of movement could also destabilize local economies, with the potential mass migration of workers to regions with better opportunities or living conditions, causing significant socioeconomic imbalances. Beyond economic issues, teleportation would raise serious privacy and security concerns. The ability of a person to teleport anywhere instantly could be exploited for nefarious purposes such as espionage, property invasion, and other crimes. New regulations and security technologies would be needed to control and monitor the use of teleportation, ensuring it is not used for illicit activities. Individual privacy would also be threatened, as the possibility of tracking teleportations could lead to a significant increase in surveillance. Quantum teleportation, a fascinating field of modern physics, is based on fundamental principles of quantum mechanics. Two essential concepts are superposition and quantum entanglement. Superposition is the phenomenon where a particle, such as an electron, can exist in multiple states at once. This means that until observed, the particle can be in several places simultaneously. This principle challenges our classical perception of reality and is fundamental to quantum teleportation, where the state of one particle is transferred to another without the original particle physically moving. This ability to be in multiple states simultaneously is what makes quantum teleportation so intriguing and full of potential. Quantum entanglement is the second pillar of teleportation. When two particles are entangled, their properties become interdependent, so that changing the state of one particle instantly affects the other, regardless of the distance between them. This phenomenon was described by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935 and is known as the EPR paradox. Although Einstein referred to entanglement as spooky action at a distance, later experiments, such as those conducted by Alain Aspect in the 1980s, confirmed the existence of this phenomenon. These experiments showed that entangled particles share information instantaneously, violating the classical notion that no information can travel faster than light. Experimental advances in quantum teleportation began to take shape at the end of the 20th century. In 1997, Dick Baumeister and his team at the University of Innsbruck performed the first quantum teleportation experiment, teleporting the quantum state of a photon to another over a distance of a few meters. More recently, in 2017, a team of Chinese scientists led by Jianwei Pan teleported photons between Earth and an orbiting satellite at a distance of 1/200 kilometers. These historic milestones demonstrate the feasibility of quantum teleportation over great distances and indicate that we are on the right track for future applications. Although we are still far from teleporting objects or humans, these experiments represent significant advances in understanding quantum phenomena and the potential realization of teleportation as a practical technology. Teleportation has been a central theme in science fiction for decades, capturing the imagination of writers, filmmakers, and fans around the world. One of the most iconic representations of this technology is the Star Trek series, where the phrase, "Beam me up, Scotty," has become synonymous with instant teleportation. In the Star Trek universe, the crew of the Enterprise uses a device called a transporter to dematerialize their bodies and reassemble them in a different location, eliminating the need for long and tedious journeys. This vision of teleportation as a means of instant and safe travel has fascinated generations, shaping the way many people imagine the future of mobility. Another notable representation of teleportation is the movie The Fly, directed by David Cronenberg. In this narrative, a scientist invents a teleportation machine that accidentally merges his DNA with that of a fly, resulting in a horrific genetic transformation. Unlike Star Trek, The Fly explores the dangers and unforeseen consequences of the technology, presenting a darker and more cautious view. While Star Trek shows us a utopian future where technology is mastered and beneficial, The Fly serves as a warning about the possible dangers of advancing without due caution. Science fiction plays a crucial role in inspiring technological advancements, acting as a fertile ground for innovative ideas that later become reality. Many technologies we use today, such as cell phones and tablets, were inspired by devices first seen in works of science fiction. Teleportation, although still in the realm of imagination, continues to inspire scientists and engineers to explore new concepts in physics and engineering. The stories we tell about the future help shape it, and science fiction remains a powerful driving force for innovation. Do you think that someday we will be able to use teleportation so frequently that it will become as common as the means of transport we use today? Leave your opinion in the comments. See you in the next video.